Hey there, hope you're doing good. A company came to me last year with the following problem. Their tech wasn't meeting their requirements. When they onboarded more customers, the system crashed. It was slow, it was buggy. New bugs would manifest every week or two. Fixed bugs would keep reappearing. When they added new features, in the process, existing features broke. Customer data went missing. Customers were unhappy. The team members, both engineering and non-engineering, were unhappy. The system was insecure. Velocity of development was slow. When I looked into it, I realized that the backend was broken. The mobile apps were broken. The front end was broken. The database was broken. The APIs were broken. How do we fix all this was the question. In this situation, the first thing we need to realize is the amount of time it takes to fix a shoddy system is more than the time it took to build it. If it took a person year to build it, maybe 2 people working for 6 months, right? That's 1 person year. If that is what it took to build a shoddy system in the first place, it will take more than a person year to fix it. Non-technical founders look for a quick fix, a shortcut. But unfortunately, in this situation, there is none. In fact, the tendency to take shortcuts is what created this problem in the first place. Now that we have recognized that fixing this is a mega project, how do we go about it? There are 2 ways at a high level. We can refactor or we can rewrite. What do these words mean? Let's look at this example. You have a system consisting of 5 components A, B, C, D and E. A could be the database, B could be the load balancer, whatever they are, right? Or the front end. A, B, C and D are defective. They need to be fixed. That's why they are in red. E works well. That's why it's in green. So let's take this example and work out how we would refactor it and how we would rewrite it so that we can compare the two. First, let's take refactoring. You start with the system and you pick one of the broken components A, B, C, D and you fix it. So you have picked A and fixed it. Now you have 3 broken components remaining. You pick one of them and you fix it. Now we are down to 3. 3 working, 2 needing work. Pick one of the 2 that is broken, B or D, and fix it. Then fix B. Now you have a green system. Everything is good. This is how you go about refactoring. Now let's look at rewriting. Starting with the same system, A, B, C, D, E, with E working well. The first thing you do when rewrite is you set up a new system on the side, separate from the older system. With refactoring, what we looked at earlier, you had only one system which you kept improving over time. Here, that's not how we are doing it. We are building a separate system. Initially, it's empty. Then we take the good parts of the legacy system and move them to the new system. In this case, E works well, so we added it to the new system. Then we pick one of the broken components. We rewrite it or we fix it, however it may be. Then we add it to the new system. We have picked A and fixed it and added it. Notice that A is green on the right side because it is good. We are not allowed to put shoddy pieces into the new system because then the new system will become another legacy system, which defeats the whole point of this exercise. So we can't pollute the new system. Whatever is in the new system has to be good. And you can't say I'll add it today and fix it next week. No, you fix it first, only then you add it to the new system. Then you pick one more component, C, then one more, D, then one more. So now you have a copy of the old system with all the same components but fixed. So you have 2 systems in parallel. Then you copy data from the legacy to the new system. Then you send traffic to the new system. Until now, you have been sending traffic to the old system. After a quarter or so, you turn off the old system on the left The legacy system is removed. This is how you go about rewriting a system. So refactoring means improving it in place. Rewriting means building a separate system. So now that we understand what these terms mean, which should we go for? The answer is we should refactor. Why? A few reasons. When you refactor, you see an improvement sooner. If you see here, you started with this. When you fixed A and launched it, immediately the system improved, right? With rewrite, the entire new system has to be built and deployed before you see any benefit. So if you have a project that goes on for, let's say, 6 months, you don't want to wait 6 months before you see any benefit from the project. You want to see some benefit every month. That's the first reason why you should refactor. The second reason is when you rewrite, there is no guarantee that the decisions you are making will solve the problems. When you refactor, you deploy each change as you make it. That gives you validation. Validation is always good. You want to build a little, release it, validate it, build some more, release, validate. You don't want to sit in a vacuum for 6 months, build an entire system and launch it, because you can find out at the very end that you did it wrong. The third reason you should refactor is when you rewrite, even if you assume you fix the old problems, you might introduce new problems because you're building from scratch. Whereas with refactoring, you improve only what needs to be improved. You don't make anything worse. In fact, that's the first rule of refactoring, never make anything worse. The fourth reason you should refactor is if you rewrite, you have to migrate data and transfer traffic over, which can be a project in itself. So let's say you migrate data first. So by here you have finished building the new system, you copy data. Then the instant you're done copying, it's already out of date because the legacy system is still receiving traffic. So now you have to do an incremental data copy, which adds more complexity. You have to have some logic that figures out what data got changed and copy that over only. And when you copy it, you should be careful to overwrite it in the new system, not make a copy of it. So let's say we are building a notes app. If I edit a note, that edit needs to be propagated to the new system. But we shouldn't create a duplicate note with the edit. The same note should be edited in place. And when you send traffic to the new system, the transfer of traffic from the old to the new system takes time. And for a while, both are active, which adds another level of complexity. And when you're copying data while simultaneously serving traffic, you have two things that step on each other's toes. So all this is huge engineering complexity. And complexity is the last thing we want. Demons lurk there. Complexity is what causes projects to keep extending perennially, where every month you are told it will take another month. Complexity has unknown unknowns. We can't foresee the problems. We don't want it. The fifth reason why you don't want to rewrite is companies sometimes end up running the new and the old system for multiple quarters, doing double work, sapping their engineers' time. When you refactor, this problem doesn't exist because there's only one system. So these are the 5 reasons why you should refactor instead of rewrite. To summarize, first, you see improvements sooner. Second, with rewrite, you are not sure because you don't have validation. Third, rewriting can introduce new problems. Fourth, rewriting has more engineering complexity. Fifth, rewriting means running 2 systems in parallel, sapping engineers' time. This is why you should refactor. Some non-technical stakeholders think that rewriting is a lot of work and refactoring is a small project. That's true if you're refactoring only one part of it. But if you go back to this system, where 4 of the 5 components are broken, obviously it's not going to be a small project. If only one component were broken, it would be a small project. So in this case, you are not prioritizing rewrite over refactor because it will be done in a month, whereas refactor over rewrite because rewrite will be done in a month and refactor will take a year. That's not the case. It's not about the amount of time or the cost. Both of them can be a lot of work. It's just that refactoring delivers value incrementally and at lower risk. You should refactor. The only exceptions are if you are switching languages, like moving from Java to Ruby, or frameworks like Angular to Vue. In that case, refactoring is typically impossible and you have to rewrite. Otherwise, refactor. If you'd like me to set your team up for success, my consulting link is in the description.